All right, so this is going to be a pretty fun series. I'm going to be doing a lot of videos about JavaScript and functional programming. So this is video one. We're going to be talking about keeping functions pure and what that means and easy ways we can do that with JavaScript. And also, like, hopefully you'll see in this video the benefits of keeping functions pure and how it's a lot easier to eliminate side effects. I'm just going to start writing some code on the screen. So to keep a function pure, basically it just means there's no side effects. So let's say, for example, we want to associate a new key value pair to an object or something. So we can have this function called like associate, and then we're going to assign that to the function here. Oops. And associate's going to take in a key value and an object, right? So basically what happens is an object here, we're going to be doing like here at a certain key, we're going to assign it the value. Okay. So what this does is like we've got this user up here. So const user, and this is going to be an object. And the user's got a name, and the user's got an age. But let's say with this user we want to add like, right here, favorite programming language, right? So if we want to associate, that new favorite programming language, what happens is if we've got side effects, so I'm going to call this associate function here, and we can pass in like a new key value for the object to use. So the key would be favorite lang, and then let's say the value is JavaScript, right? And then we're going to pass in user. Okay. So what we're wanting to do is we're wanting to make sure that this result associates JavaScript as this user's favorite language. But what's going to happen is we'll see here soon. So hold on. Let's see. Console log. Let's console log that result. Okay. So if I just run node index.js, see it gives us undefined. That's what it's logging out. So this is a really good example of like what a side effect is doing. So to solve this, and actually hold on. So before we solve this, I think like we should have had more than just undefined. We should have had like a user in there. Let's see. Yeah, see, it's just giving us undefined. To the code and see what's going on. Oh, I see what I just didn't log in. Okay, here we go. I need to put in the user here. Okay, so what that's doing is, see, I want to see that we've got the user and then undefined. So this undefined, we really want it to append onto this user object. Let's see how we can go about this without changing the user object. We don't want to have those side effects going on. So let's go into index.js, and instead of having associate change, manipulate the object like that, let's go ahead and we got to go up here, and we're going to return. Yeah. Okay, so instead of object at key, what we can do is we can spread in object, just like that. And looks like I forgot to do this. Okay, so we can spread in the object, and then here, what we'll do is we'll just have key assigned to value, but this is an object, so we're gonna change this. Instead of assignment, it's gonna be assigned how objects are assigned values. So let's give this a shot. Okay, so you can see right here, we've got the user, and then now, since we're not having these weird side effects and stuff, it's basically created a copy. And so we got name, Derek, age. Oh wait, why are we doing that? Oh, that's funny. Okay. Okay, so this is working. This is and this is a really good example of like why you should try to avoid having side effects in your code. The idea here is we don't want to mutate state, right? So we've got this object, and before how we were doing it is, instead of creating this copy of the object, we were actually operating on that object in memory. Like we were literally operating on that object in the memory. So what this is doing is it's creating a copy, and instead of manipulating, the original object, it's just creating a new one and it's appending to it. So what's nice about this way of thinking is everything's like a lot more modular. You can take functions, like you'll create small little functions like add, right? So we'll have add, it takes X and Y, and it returns X plus Y. And you can take these functions and, plug and piece them together and use them almost together like little Lego blocks or something. So the problem though is like with computer science and the way a lot of computers work and stuff, they really are Turing machines. That they operate more like Turing machines. And if you're familiar with like the church Turing thesis, like yes, everything can basically be calculated with lambda calculus and have the same result as you would with a Turing computer. But in the real world, like a lot of computers don't actually operate that way. So, for example, like if we do console log, that, believe it or not, is a side effect, right? So computers tend to work in this way, but that doesn't mean that we can't write more modular code that is clean and reusable. So like for example, this add, like what if we did like let's just say we called add and we passed in like 4 and 8, right? So that would basically just take 4 and 8 and add them together, and we would get the 12. So that's one way to do it. But like if we were to do this in sort of like a Turing machine kind of way, where we're doing like let 4, right, and then we're operating on let num equal 4, and like we're operating on this data. So I'm just going to get rid of well, actually we'll leave all that. So right here we have like let num equal 4, and then let's say we created add, and then it took actually, you know what, no, let's not do that. Let's do X here. Yeah, so add, and then we do like X, and then that returns like Y plus equals X. Or like let's actually do that the other way. So this would be X, and this would be Y. Okay, so this is very side effecty, right? It's the same thing. We're doing the same thing essentially, but like we're relying on this state of X right here, and we're literally changing this state. Well, like, yeah, you'll notice, like, if you do a lot of those leak code problems and stuff, you'll notice that, like, with a lot of algorithms, this is a very very natural way to go about solving algorithms. You know, you create your state, your variables, and then you have functions that operate on these variables. And there's nothing really wrong, like, with this approach at all, especially for a lot of the other underlying algorithms and stuff. But what happens is when we're working with concurrency and, like, the modern internet, how the internet actually works today, we're starting to see that, like, you know, with functional programming languages like Elixir, Elm, and stuff, like, it's a lot friendlier with how asynchronous transactions work, and how basically functional programming is really helping us in this problem of concurrency. All kind of making sense a little bit, and you know, I'm going to be doing some more videos like this where we dive in and we kind of just dissect, you know, different topics. So I think in the next one, you know, maybe we'll start working on, like, higher order functions, understanding, you know, how you can actually operate on functions as data as well. Just like, you know, you would operate on an object or variable. You can also operate on functions. So I think that's what we'll be doing next here. And if you like this video, you know, give it a like. Definitely helps out the channel, helps out the YouTube algorithm. And yeah, let's keep these videos rolling.